For this project, we created an environmental sensor that records light and temperature values using an Adafruit data logger shield and an Arduino. First, we designed the light and temperature sensor circuits on Tinkercad. On Tinkercad, we were able to explore Ohm's law, how to use a breadboard, how to create a circuit and write corresponding code for a blinking red light, and how to design circuits with light and temperature sensors. These exercises were useful as they provided an easy and no-risk way to learn how circuits and the components worked with an Arduino. Tinkercad also provided a user-friendly interface that was especially useful when debugging and troubleshooting. Then, we implemented the circuit design on Tinkercad with a breadboard to ensure the circuit worked without issues. We created the data logger using the Adafruit data logger shield. We attached headers in order to connect the data logger to the Arduino. Next, we programmed a real-time clock chip to keep track of time, and configured the SD card to store our data. Then, we positioned the wiring similar to that of the breadboard setup onto the Adafruit data logger shield, and secured the wiring and data logger shield by soldering the two components together. The pre-written code for the project was uploaded into the Arduino program, and our sensor was ready to test. Once tested, we placed our sensor in the two different locations and gathered light and temperature data in intervals of 10 minutes. Once the data collection was finished, we uploaded it and plotted the data into Excel.
We chose to monitor light and temperature at two different locations in the EER. Our first location was a study room located on the ground floor. This small room has no natural lighting and is illuminated with a bright LED light. Most of the walls are made out of drywall with one made of glass, and the floor is carpeted. Our second location was the ground floor atrium of the EER. This large open space spans 3 levels and during the day is exposed to a lot of natural sunlight through the glass wall of windows and the glass ceiling. LED lights are dispersed throughout the atrium to supplement the lighting of the space during the evenings. Cold, hard flooring covers the entire space. We chose these two locations in the same engineering building to determine which of the two would be optimal for studying based on light and temperature, and we recorded this data over a period of 10 minutes. We recorded the data during the evening at around 8 p.m. The temperature data gathered showed that the temperature in the study room is higher than the temperature in the atrium, and the light data showed that the light level in the study room is higher than the light level in the atrium. These results were expected, given the room characteristics described earlier. It's also important to note, however, that the 3 of us were in the study room at the same time the data was collected. Given the small space, that could have contributed to the higher temperature as well. We adjusted the temperature data by subtracting approximately 40 degrees Celsius from the recorded temperatures in order to reflect ambient room temperatures, since the measured temperatures were over 60 degrees Celsius, which we attributed to the Arduino board overheating.
Building the data logger went relatively smoothly, with the exception of the soldering, which improved as we progressed. We also encountered an issue with the Arduino board overheating, which likely interfered with the temperature sensor. The biggest challenge was determining what to do with the abnormally high temperature data, which we corrected by adjusting temperatures based on an educated assumption. When determining which locations to monitor, we wanted 2 similar locations. We chose these locations because these are 2 locations that many engineering students frequent during their time at UT. Monitoring the differences between light and temperature data for these 2 locations would be interesting given that they are both in the same building. We found that both temperature and light values were lower in the atrium than in the study room. Some parameters that could explain the difference seen between the 2 locations could be the square footage of the rooms, given that the ground floor atrium is much larger than the study room, as well as ventilation, presence of natural light in the atrium versus the bright white light in the study room, the amount of people in the rooms, and the different floorings. Since we wanted to compare which location would be more optimal for studying, we monitored for 10 minutes because it takes approximately 10 minutes to get settled into the study spot. Since our data showed that it was warmer and brighter in the study rooms during the evening, we've concluded that it's better to study in the EER study rooms than in the ground floor atrium. Our finished design is a good beginner model of an environmental light and temperature sensor. It is easily adjustable and can be reconfigured as needed and collects the data specified. However, we found the sensors to be slightly inaccurate and the Arduino to be prone to overheating. Looking forward, acquiring more accurate sensors and using a more robust computer system would help create a better design. It was enjoyable to construct a sensor that was able to collect relevant data that we could relate to the comfort of certain study spots on campus. Not only are the 2 parameters we measured taken into consideration when looking for the ideal location, but it was interesting to see how these 2 measured values varied with locations only being a few hundred feet away from each other. The data logger can provide valuable insight for educational systems. Educational institutions can utilize this device in order to design adequate study spaces for their students.